So what is sharding? Sharding is essentially a practice of dividing the network into smaller fragments, or shards, each capable of independently processing its own transactions and smart contracts. Think of it as running several smaller blockchains concurrently within the larger network. This parallel processing significantly accelerates transaction speeds. Each shard maintains an independent state, housing a unique set of account balances and smart contracts. To simplify this further, let's say you have a single road with 1,000 vehicles all moving in the same direction, each vehicle trying to get to its respective destination as quickly as possible. This road is bound to have a bottleneck in traffic, a choke in movement that ultimately grinds everyone to a halt. Now, let's assume instead of one single lane of road, we now have 20 lanes moving parallel to one another. By dividing the workload equally between the lanes, each lane can take 50 vehicles moving smoothly through it instead of the 1,000 it was supposed to handle previously. That, in simple terms, is the idea behind sharding. Did you know that the concept of sharding isn't originally from the blockchain world? It's a technique borrowed from traditional database architecture, used to improve the efficiency and speed of operations. In database systems, sharding refers to dividing a database into smaller pieces, or shards, each capable of being managed and operated independently. This allows for parallel processing, improving the speed and performance of database queries. As blockchain technology developed and the number of transactions grew, it became clear that the existing infrastructure couldn't scale to handle the increasing demand. Transactions were slow, which in turn meant that fees were high. The blockchain community realized it needed a solution. Enter sharding. Inspired by traditional database architecture, Ethereum's developers proposed the concept of sharding for blockchain networks back around 2018. Their idea was to split the entire Ethereum network into smaller pieces, or shards, each capable of processing its own transactions and smart contracts. This meant that not every node had to process every transaction. Instead, different nodes could handle different shards, spreading out the workload and increasing the network's overall capacity. It was a revolutionary idea and a major step towards solving the scalability problem faced by blockchain networks. Now, here's where things get even more interesting. There reached a time when newer blockchains being released decided to up the game as far as sharding is concerned, thereby creating a brand new upgrade, dynamic sharding. In contrast to traditional sharding, where the number of shards remains fixed, dynamic sharding flexibly adjusts the number and size of shards in response to network load. In essence, it's a sharding model that is nimble and adaptable, responding in real time to the requirements of the network. This dynamic quality is a groundbreaking development for improving blockchain performance. Dynamic sharding hinges on two pivotal components: split events and merge events. A split event gets triggered when the network load escalates. The blockchain splits into smaller shard chains, each tackling a specific range of transactions, thereby increasing the network's capacity. On the flip side, a merge event occurs when the network load diminishes. The shard chains merge back, reducing redundancy and overhead, thus promoting overall efficiency. Let's now explore a real-world example of dynamic sharding in action. We'll be using the all-new Venom blockchain as a perfect playground for the concept in action. This example will help us understand how this innovative mechanism functions within a live blockchain ecosystem. Picture this. As the Venom blockchain starts to experience a surge in transactions, the network activates a split event response. Here, the blockchain splits into smaller shard chains, each responsible for a specific range of transactions. It's like dividing a large task into smaller parts so that each can be tackled independently, resulting in higher efficiency and scalability. During the split, an additional group of validators is assigned to each shard chain. These validators maintain the security and performance of the newly formed shard chains. Each validator knows in advance which shard it needs to validate, ensuring a seamless transition and continuous operation. Now, let's imagine the network's transaction load decreases. Here's where the network triggers a merge event. The sibling shard chains merge their states into a single shard chain. This process reduces redundancy, promotes efficiency, and aligns with the network's current load. This dynamic cycle of splitting and merging ensures that the Venom blockchain can scale up and down in response to the network load. It's like having a living, breathing organism that adjusts to its environment. This flexible, real-time adaptation is the true genius of dynamic sharding. The Venom blockchain's dynamic sharding model exemplifies how blockchain technology can meet demands of scalability and efficiency without compromising on security and decentralization. It truly brings the concept of dynamic sharding to life and illuminates its potential in revolutionizing the blockchain landscape. While dynamic sharding brings about numerous benefits, it doesn't come without potential challenges. Here are a few. First up is cross-shard communication. Imagine each shard as an isolated island. Now, transactions occurring within an island or a shard are easy to handle. But what happens when a transaction needs to take place across two different shards or islands? This cross-shard communication can be complex and difficult to manage, resulting in potential latency issues. Next, we have security. While sharding increases scalability, it can also potentially decrease security. Each shard typically has fewer nodes, making it easier for malicious actors to take over a particular shard, an attack known as shard takeover. Although Venom blockchain has mechanisms in place to mitigate such risks, the concern still exists in the broader sharding landscape. Then we have the issue of data availability. When data is spread across multiple shards, ensuring that the necessary data is available when needed can be a challenge. Validators might need to access data from another shard, which can lead to delays and complications. Lastly, there's the challenge of shard balancing. The network must dynamically adjust the number and size of shards to balance the workload evenly. Too many or too few shards can lead to inefficiencies, making shard balancing a critical yet challenging aspect of dynamic sharding. There you have it, a comprehensive guide to the world of dynamic sharding. This captivating concept holds the potential to drastically enhance blockchain scalability and efficiency. While the challenges faced by dynamic sharding solutions are real, it's important to note that they are actively being addressed by the blockchain community. The Venom blockchain, for example, is employing advanced techniques and mechanisms to mitigate these issues. The constant evolution and progress in this field show that we are on the right path toward building a more scalable and efficient blockchain network. If you loved this video, smash that like button, subscribe if you're new here, and share with your friends to benefit. As a Learn and Earn channel, we always put out 3 simple questions at the end of each video, where you stand a chance of winning cool rewards by participating in our quests. Find the link in the description below. Until next time, stay curious and stay informed.